Honors Pre-Calculus Final Exam Review 2013, number 62. So we're still verifying identities. Make sure you check number 60 and 61 for some general comments. In this one, we have 1 plus tangent squared s, is what that's supposed to say, times 1 minus sine squared s equals 1. So there's our basic problem. Now, one thing we might consider doing, the letter s is a little difficult to work with here because cosine, sine, they all have s's in them. So we're perfectly fine to change that to a theta or an x. Let's call it x. I like x. It's a nice variable. It stands for xylophone and xenophobia and all kinds of nice words. All right, so I've just rewritten it with a different letter to make it a little easier to handle. Now, we should probably be considering two things that we did in our last two problems. We should consider writing this tangent in terms of sine and cosine, and we should consider foiling. Now, we can do those things in either order. My personal preference is to FOIL it first because I don't like to FOIL with a big old fraction as part of my FOIL. However, some people like to change it to sine and cosine first because then as they're FOILing, they can cancel right away. So that's your choice. So I'm going to FOIL first. I'm going to get 1 plus, this is going to be times a negative, so it's minus sine squared x, and then I have plus tangent squared x, that's this product, and then tangent squared times negative sine squared. So that's going to be minus tangent squared x sine squared x. And that somehow is equal to 1. Now, it's not very convincing. It doesn't look like it should be equal to 1, but perhaps it is. Let's find out. So one thing we could do right away is subtract these 1s from both sides. That's a little bit tempting because it'll at least simplify my problem. But on the other hand, I'll have 0 on the other side. I'm not sure it's a very helpful thing to do. Let's work instead with this sine squared and tangent squared and see what we can come up with. So I have 1 minus sine squared x plus tangent squared x minus, actually, you know what? Let's put everything in terms of sine and cosine. So this is going to be sine squared x over cosine squared x times sine squared x equals 1. Now I have this dreadful problem that I'd like these sine squareds to cancel and they don't. And I also said that I would like to put the tangent in terms of sine over cosine as well, and I haven't done that. So let's try doing that, and let's try subtracting this 1 off from both sides because I think that may be just complicating the issue. But you can see I'm also just strategizing, right? I haven't looked at this problem, so I'm saying let's try some things and see what works. So I'm going to subtract 1 from both sides, and then we're going to bring down the negative sine squared x. Let's now put this in terms of sine squared and cosine squared, sine squared over cosine squared. And then here I have minus, well, I guess it's hard to avoid wanting to put that in terms of, that's sine to the fourth, sine fourth x over cosine squared x. And somehow that should equal 0. That's interesting. So I think now the next thing I might consider is that I see some cosine squared denominators here. So I'm going to multiply. I think I'd like to multiply both sides by cosine squared. And I sort of am thinking I'd like to put that sine squared over there. Because, well, let's just multiply both sides by cosine squared and see what happens. So I'm going to multiply both sides by cosine squared x to get rid of my denominators. And then I end up with negative sine squared x cosine squared x plus sine squared x minus sine fourth x equals 0. Now, that doesn't look too happy. Except that the other thing that I notice now is that now all of my terms have a sine squared in them. That's something I like. So let's try dividing that sine squared out of all the terms. So I'm going to divide both sides of my equation by sine squared x. So we'll divide this side by sine squared x. Now, I can reduce the sine squared with every single term. This sine squared will cancel, this sine squared will cancel, and this sine squared will reduce back, this was sine fourth. It will reduce back to sine squared, which I like quite a bit better. Now I'm going to have negative cosine squared x. Sine squared over sine squared gives me plus 1, and this one's going to leave me with minus sine squared x. and that equals 0 divided by sine squared x equals 0. Now I like this because it has my favorite things, which are cosine squared, sine squared, and 1. So what I'll do is add, I don't like these negatives, so we'll add the cosine squared and the sine squared, and we'll add that to both sides. And then we get these canceling, and these canceling, and then I have 1 equals cosine squared x plus sine squared x. Then, going back to my Pythagorean identity, cosine squared x plus sine squared x equals 1, so I end up with 1 equals 1, and I have verified that identity. It was a bit of a long road to travel. This one was not so easy. So foiling it out was one thing, changing everything to terms of sine and cosine was another. Multiplying by a denominator that with this denominator was not helping or making anything clear, so we multiplied both sides by that cosine squared. And then noticing that we have a common factor, so I could really, another way to show this would be to factor that sine squared out. But since I have a common factor in all three terms, I can divide it on both sides. It's nice to divide by 0 because it stays the same. 0 divided by anything is 0. Reducing all this and then recognizing that I have a Pythagorean identity, so just rearranging it so that I can clearly see that Pythagorean identity and take advantage of it. That's number 62. And by the way, there probably are several other ways to do number 62 also, so if you find another viable way to do it, that's excellent.